All right. Good morning, Tigers. We are going to be working on lesson 34. Lesson 34 is an investigation. Okay, so I'm not going to spend a whole big long time working on this video. Um, so this, I'm going to work a couple of things. I'm going to set you up, and then you're going to do this packet pretty much on your own. Um, as always, you can check the key to check your answers against mine. However, I'm not uploading the key right away, so you need to do some stuff on your own. You will need Desmos for this activity, so I will help you get some stuff set up on Desmos. And feel free to rewatch this video because I'm going to work some of it, but then I'm going to give instructions on each task. So if you want, you can keep the video open, listen to the instructions for task 2, pause it, do task 2, then listen to the instructions for task 3, do task 3. So however you want to do it, it's completely up to you. Okay, so we are modeling with functions, and we're modeling with all the functions we've done so far. And we have done, that was misspelled, but we have done linear functions, quadratic functions, and exponential functions. So I don't know if you remember, but linear functions graph in a line. It has a constant rate of change. Quadratic functions graph is a parabola. We have an increase and a decrease. And an exponential will increase a little bit, and then dramatically change how quickly it's increasing by or decreasing. You can have exponential decay as well. Okay, so task 1, analyzing data. Harry, Hermione, and Ron all use Wizardgram to share their photos online and to track how many people follow their photo stories. The people who choose to follow the photo stories can also stop following or unsubscribe at any time. After the first 8 months, the data for each of the monthly number of followers was compiled and is shown in the table below. All right, so they've opened their Wizardgram accounts and they're monitoring how many followers they have. We have Harry's followers, Hermione's followers, and Ron's followers. Okay, so number 1 says use the word bank below to describe any patterns you notice in the table for each person. All right, so let's look at Harry's followers. If we look, is the data increasing or decreasing? Is it increasing by roughly the same amount? Is it increasing by a dramatically different amount? Does it have a common difference or a common ratio? These are things that you need to ask yourself. Does it look to be linear, quadratic, or exponential? So let's look at Harry's followers. From 37 to 42, we have added 5 followers. From 42 to 46, we've added 4. From 46 to 52, that would be 7. Then we've added 4 and another 7, and then we've added 3, and then we've added 6. So if I look, I've added 5, 4, 7, 4, 7, 3, 6. So I've added each time. It's not extremely constant, but it's not like I added 2, then 12, then 36, then 4, then 58, then, it's all in the same range, everywhere between 3 and 7. So I would say that Harry's data, it is increasing, and it's a steady increase. Of about 3 to 7 followers a month. If you were to pick linear, exponential, or quadratic to model this, though, what would you pick? It doesn't have an increase and a decrease, so I wouldn't pick quadratic. And it doesn't have a dramatic change in followers, so I wouldn't pick exponential. So I would say it's relatively linear. Okay, let's look at Hermione. Okay, so Hermione, we've added 3. From 5 to 9, we add 4. From 9 to 6, we add 7 from 16 to 33, that is going to add 17. From 33 to 65, that adds about 32. From 65 to 128, that is going to add 63. Let's see, and then this next one will add 123. I had to think about it for a minute. So if I look, these are increasing the whole time. It's not an increase, then a decrease. But I'm almost, like, look how dramatic that increase is, though. Or let's look at this. If I were to maybe double this, like 2 times 2 is 4. That's 1 off from 5. 5 times 5 is 10. That's 1 off from 9. 9 times 9 is 18. That's a little bit off from 16. 16 times 16 is 32, which is pretty close. So I'm pretty close to double each time. So Hermione, it's an increase, but it's a dramatic increase. It nearly doubles each month. Okay, so since it's not a steady increase, I wouldn't say linear. It doesn't do that increase decrease or decrease increase. So I wouldn't say quadratic. So that leaves me to believe that's exponential. And then let's look at Ron. Okay, so from 16 to 29, we add, let's see, 13. From 29 to 38, we add 9. From 38 to 42, we're adding 4. Adding 1. Here we're losing 4. Here we're losing 8. And here we're losing 11. All right, so with Ron's, we had an increase that slows down and then a decrease. So we have an increase, then decrease. So my followers increased, then they started decreasing. So it changes direction. So I would consider that a quadratic function. Okay. Number 2 kind of gave you the answer in number 1 for number 2. But number 2, identify each type of function that would best model each person's total number of followers. So we did say Harry would be linear, Hermione would be exponential, and Ron would probably be quadratic. And if we were to explain, in order to be linear, you'd have to have a common difference or a constant rate of change or a slope. And we don't have a perfect slope, but if we're doing a regression or if we're doing a trend line, we can do a line of best fit and get a slope off of that. So this would have a common difference on a trend line. All right, Hermione. So again, hers is not exactly doubling, but it's close to it. If I were to do an exponential regression, what that would do is that would do the same thing as a linear regression. We could do a scatter plot and come up with an exponential curve of best fit, which is just like doing a line of best fit, but it would be an exponential curve, and we could get a common ratio from that. So it would have a common ratio for the exponential curve. And then poor Ron with his increase and decrease. The quadratic function, we can see it has symmetry. We could say the axis of symmetry would be at about month 5. So it has some symmetry, and it changes direction. So quadratic's going to fit this the best. Okay. So make sure you've still got the same notes that I have. And then let's move on to the next page. All right. Number 3, why did you choose what you did for each person? I'm going to let you answer that. Please don't put because that's what Miss Gallant said. Give yourself some more credit than that. Give yourself a good answer. All right. All right, task 2, using regression. So I want you to do this on your own. I want you to follow the instructions and do this. But basically, this is something you're going to do in Desmos. And we did quadratic regression in the last lesson. Okay, so I do have some hints that you can use. All right, so let me get into Desmos real quick. So remember, the first thing you want to do is open a table. And you want to type your data in your table. So we have months 1 through, 1 through 8. So you can type in 1, 2, 3, all the way to 8. And then you can type in Harry's data here. Now, if you want to, you can have a Y2 list and a Y3 list. Okay, you can do a Y1, a Y2, and a Y3. And then after you graph your data, you can do your regressions down here. So when you do your regressions, you're going to have Y1 with a regression, Y2 with a regression, and Y3 with a regression. You can do 3 separate tables if that's easier, or you can just make one table. I would just make one table and make it easy on yourself. So the linear function, whichever one of these is linear, do your linear regression in that box. Whichever one is exponential, do your exponential one in that box. So you just want to make sure that your data matches your, like the Y1 matches with your data for Y1. Your line for Y2 matches with your data for line 2. So that's why we have the 1, 2, and 3 here. When you type in, all of them will use X1 though, because we only used X1 as our, X1's our only X variable. So we'll use X1 in the rest of these. Okay, so again, if your linear data is in the 3rd row, you would change this to like Y3 equals, or is regress against MX1 plus B, just depending on what you do. All right, so you're going to type in your data. You're going to type in your 3 regressions. Make sure that your, whatever your formula is, it matches, or whichever formula you use, you match your table. You match your variable in your table. And then you're going to write your equations down. So this is just like what we did yesterday, or whatever day y'all did the last lesson. All right. So that's kind of all the hints I'm going to give you here. If you can't see your data, change your X and Y axis. Use the little wrench button. All right. So task 3, once you have your data, you're going to answer your questions. It's going to ask you how many followers does he gain each month. That should relate to your slope. Okay, for number 5, that should relate to your slope. Hermione's, she's saying that she thinks hers is doubling. So that needs to relate to the common ratio or the growth factor. Okay, let's see. All right, task 4, task 4, trying to remember my Roman numerals. First off, I want you to label these. So let's make sure we label Harry, Hermione, and Ron. Your x-axis should be the number of months. Your y-axis should be the number of followers. All right, so make sure you have labeled your graphs. You've scaled them correctly. Remember, you can use the scale on Desmos, so adjust your scale on Desmos and then you can just pretty much copy, but make sure you can see each trend and what it's doing. All right, after graphing, answer questions 8 and 9. Okay. All right, number 10. Again, we are just going to answer the questions for task 5. So task 5, let's see. We're actually comparing the 3 models. We're comparing the 3 functions and the 3 graphs. So which of the 3 students has a constant rate of change? That would be whichever one is linear. So, and then you need to explain. Who had the greatest numbers of followers initially? That would relate to your y-intercept. So look at your y-intercept to kind of make that decision. Okay. When it says justify your response using the function, so here you're going to use those 3 functions that we wrote in task 2 for Harry, Ron, and Hermione. So I'm going to go ahead and set this up here. And when it says use the function, okay, remember we're wanting the greatest number of followers initially. So what we're looking at is when x equals 0 or when time is 0. So you're going to get those 3 functions and plug 0 in for x and simplify. Okay. Okay. Let's see. All right. 12, 13, and 14 are just some reasoning questions that I want you to think through. And then let's look at task 6, comparing models. Okay, so 15. Write a new function that describes the total number of Harry and Ron's followers together. So since we want their followers together, we're going to add Harry's function. Plus Ron's function. I'm going to let you do that on your own, but I want you to add the 2 functions together. And you should get a new y equals blah, 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 blah. Okay. 16, 17, reasonable domain and range. 17, will the number of Hermione's followers exceed the total of Harry and Ron's combined? That's just a logic question, thinking through it. Okay. And task 7 is some practice. All right. So we have Fred and George have started a business. You're going to do the exact same thing that you did throughout the lesson. So what I would do is after you finish 17, maybe check your work with the key, and then come back and try task 7 on your own. One thing I do want to change is if we go down to part C on 21, it's the rate of increase per month. I just had a little typo there. Okay. All right. And then I'm trying to see, I think that is it. So good luck. It is investigative. So I hope that I've given you enough help so that you can do all of this on your own. But good luck. If you have any questions, feel free to ask the sub or to let me know, or and I will help you out as best you can. So good luck. Thank you for paying attention, and hope you guys have a good day.